DC motor repair explained step-by-step troubleshooting and maintenance. DC motors are everywhere, from electric vehicles and industrial machines to power tools and household appliances. DC motors play a major role in modern technology. But like any electrical machine, DC motors can fail over time due to wear, overheating, poor maintenance, or electrical problems. In today's video, we will learn how DC motors work, the common problems they experience, and the proper step-by-step process for repairing them safely and effectively. We will also discuss troubleshooting methods, cleaning procedures, testing techniques, and maintenance tips that can help extend the life of a DC motor. Whether you are an engineering student, technician, electrician, or beginner who wants to learn more about motor repair, this guide will help you understand the fundamentals of DC motor maintenance and repair. Now let's begin. Understanding a DC motor, or direct current motor, is a device that converts electrical energy into mechanical energy. The operation of a DC motor is based on the interaction between magnetic fields and electric current. When electric current flows through the armature winding inside a magnetic field, force is produced, causing the rotor to rotate. DC motors are widely used because they provide excellent speed control and strong starting torque. There are several important parts inside a DC motor. The armature is the rotating component that carries current. The commutator acts as a mechanical switch that reverses current direction inside the armature winding. Brushes transfer electrical current from the power supply to the rotating commutator. Field windings or permanent. Magnets create the magnetic field needed for motor operation. Bearings support smooth rotation of the shaft. And finally, the shaft transfers mechanical power to the connected load. When one or more of these components become damaged or worn out, the performance of the motor decreases and repair becomes necessary. Common DC motor problems. Before repairing a DC motor, the first step is identifying the problem correctly. One of the most common problems is a motor that refuses to start. This can happen because of power supply failure, broken brushes, loose wiring, damaged windings, or a faulty commutator. Another common issue is excessive sparking near the brushes and commutator. This usually indicates worn brushes, dirty commutator surfaces, incorrect brush pressure, or uneven commutator segments. Overheating is also a serious problem in DC motors. Motors may overheat because of overloading, blocked ventilation, bearing failure, continuous operation, or internal short circuits. Low speed or weak torque can occur when the motor receives insufficient voltage or when the magnetic field becomes weak. Noise and vibration are often caused by damaged bearings, shaft misalignment, loose components, or mechanical wear. Correct diagnosis is extremely important because replacing the wrong component wastes both time and money. DC motor repair. The repair process begins with a careful visual inspection. The technician checks for burn marks, loose wires, damaged insulation, oil contamination, broken components, and dirt buildup. Visual inspection often provides important clues about the condition of the motor. Next, the power supply is tested using a multimeter. The measured voltage should match the motor's rated voltage shown on the nameplate. Incorrect. Violation can prevent proper operation and may damage the motor. After checking the power supply, the brushes are inspected. Brushes naturally wear down over time and may develop cracks or uneven surfaces. Weak brush pressure can also cause sparking problems. Worn brushes should always be replaced with the correct type and size. The commutator must also be cleaned carefully. A healthy commutator should have a smooth and shiny copper surface. Fine sandpaper is commonly used to remove carbon deposits and dirt. Rough materials should never be used because they can damage the commutator surface. The armature winding is then tested for electrical faults using a multimeter or growler tester. Technicians check for open circuits, short circuits, and ground faults. If severe winding damage is found, rewinding or replacement may be required. The next step is bearing inspection. The shaft should rotate smoothly without grinding noise or resistance. Damaged bearings must be removed using proper tools such as a bearing puller. Direct hammering should be avoided because it can damage the shaft and bearing housing. Lubrication is then applied to the bearings using the recommended lubricant. Too much grease should be avoided because excessive lubrication can increase operating temperature. After cleaning, testing, and replacing damaged parts, the motor is carefully reassembled. That all bolts must be tightened properly, wiring connections secured, and alignment checked carefully. Finally, the repaired motor undergoes testing. The motor is first operated without load. Technicians observe the current draw, temperature, vibration, sparking, and rotational speed. Conclusion: DC motor repair requires proper knowledge, correct tools, careful troubleshooting, and strong attention to safety. Understanding the function of each motor component helps technicians identify problems more effectively and perform reliable repairs. With regular maintenance and proper operating conditions, DC motors can provide efficient and long-lasting performance in both industrial and household applications. Learning these repair techniques is an important skill for students, electricians, technicians, and maintenance personnel. If you found this video informative and helpful, make sure to like this video and subscribe to the channel for more tutorials about electrical systems, motor repair, troubleshooting, industrial maintenance, or inventions. Don't forget to turn on the notification bell so you never miss future uploads. Thank you for watching, and see you in the next video.